Alright, I've been messing around with Modal Logic quite a bit lately, and I'm doing it because I got into formal methods, and there doesn't seem to be like an actual philosophy calculator for doing Modal Logic in like a really general way. And so I spent a while trying to combine modalities like possibly versus necessarily, which is like the standard one that you'll see in books. But I needed to combine it with temporal logic, especially because all of my tools are temporally based tools. Okay, so South Park actually has a pretty good explanation of what's going on. The Chewbacca defense takes advantage of a bit of classical logic where you say if something, then another thing is true. It will be true if the first thing is false, and it's highly counterintuitive. And so if you want to do software specification with formal methods, it would actually be nice to be able to have strong implication rather than simply material implication. And if you've seen this South Park episode for the Chewbacca defense, you'll know what I'm talking about. All right, now. Okay, so if we have a statement that says that Chewbacca lives on Endor. Yeah, well, let me get the camera in here completely. Where is my mouse? Where is my mouse? I can't see it. Oh, here we go. All right. If we have a statement that says that Chewbacca lives on Endor, and then the consequence is you must acquit, right? So this is Johnny Cochran in the courtroom saying, Chewbacca lives on Endor. That makes no sense. You must acquit, right? There's that's a reasonable sounding thing in material implication, where if you say P, then Q. But the thing is, if Q happens to be false, then this is always true. And that's like not really what you mean. What you mean is this, where possibly Q, which means it's possible, and necessarily P implies Q. And this basically allows you to stop nonsense. So the way that you implement modal logic is you start with a possible world where the only thing that you know is this square operator means necessarily, and it basically means like it's like something that's always true, like a law of physics or law of mathematics. It's not like an eventuality. If something is an eventuality, if you rewind to the past and you start moving through time, it could have gone down either way because you don't know the future, right? So of course, P is Chewbacca lives on Endor. Q is you must acquit. R is P implies Q. So these are the three things that we're dealing with. And if we have this form of possibility, then we have to come up with possible worlds. And one thing that drives me completely insane when I was trying to research how to use this is everybody seems to be claiming that there is just an arbitrary number of worlds that you can use. You can use as many as you want. I don't think it's actually like that. I think what's happening is if you have 3 variables per state, there are 2 to the 3 possibilities. But the thing is, if all we know is that not P is necessarily true, then what we're allowed to do is we're allowed to draw arrows to anywhere not P happens to be true. So P is false, 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 false here. But these other guys, there's no arrows to them, so they're basically cut off as impossible worlds, right? And the basic rule is that if it's a necessary from this state, then to the next state, it just has to point to something that's true, right? So once you've got these accessibility relations, this was part of the other trick. It's like, when can you justify the possibility relationships? Well, once you have these arrows drawn, you can see that it's possible that Q, because Q is true here, it's possible that not Q, because it's false here. It's possible that R, because R is true here, and it is possible that not R, which is false here. Now note that this is not a contradiction, because it says, Q is false. Q is possibly false, and Q is possibly true. So that is not a contradiction unless you say not on the outside of the diamond there. Okay. And dual relationships. So box and diamond in modal logical dual relationships, they have more than just to do with possibly and eventually. There's a whole bunch of modalities like dealing with time and stuff like that. So for the moment, I'm just focusing on eventual and impossible. So what this says is it's necessarily false that Chewbacca lives on Endor, right? And this here, notice the not on the outside, it literally says that the possibility that Chewbacca lives on Endor is false, or in other words, it's impossible that Chewbacca lives on Endor. And notice I should have used the not symbol for all of them, and I've used those and it didn't clean that up. Okay, but in any case, there were 2 to the n possibilities, but the thing is we ignored the unreachable states and didn't draw them. I can't tell you how much confusion that causes when you're trying to learn this logic, especially with like so few resources. Nobody ever explains that that's what's going on. But anyways, I think that clears things up a lot. So if we start in this state, and we say, hey, we're using temporal logic, we're now mixing together 2 modalities. We have the diamond for possibly, the square for the implication, but we also have something that's normally labeled AF in CTL logic, which means that for all there exists a future. And that's because that means that F over there means false. Yeah, just note that. I should use a different symbol. But anyway, it says for all in the future, if is whatever necessarily P is, and whatever possibly P is, and necessarily P implies Q, that ends up being false. Whereas for material implication, we get this crazy thing where it says if Chewbacca lives on Endor and you must acquit, and it's not a joke, that's actually right in classical logic. It's kind of nuts. But of course, if we go back to an early state, this is the first state in the state machine, you'll notice that we have all these different values of Q and R, so it doesn't even matter what Q and R are, because for all of them, it is false that P is true. Which means that it's true for material implication, but the thing is, it only points to P equals false, so it's also not possible. So, and of course, you have possibly P or Q, but you don't have necessarily P or Q yet, right? Because you have possible for both values. And of course, so you go from this state, and then you move to this state, and because you've done that, in CTL logic, you have for all futures, you must have necessarily P, you must have possibly P, and necessarily P implies Q. And what those happen to be in CTL logic is they happen to be exactly the same thing as there exists a future. However, you have to be careful. As I say, there exists a future in the state machine, and that means possibly. So it's a temporal version of possibly. It's an implicit assumption that no value changes without a time step. So we assume that that you can go, a long time ago in a galaxy far, far away to a really early state to where none of these values have been resolved yet. And then possibly Chewbacca lives on Endor. And then this necessarily always in CTL logic would be AG. It's necessary and always. There's a little bit of a trick. It took me a long time to figure out what the issue was. For all paths in the future, eventually, it's kind of like possibly, but it's inevitable. This would be like possibly the plane will crash. It means it's safe to fly because there is a way to fly the plane where you don't crash. There exists a path where you don't crash. But if it were always in the future, eventually it basically means you will crash. In the CTL, the dual of that is EG, which is like a can always, which means that there's some path that you can pick where you don't crash, right? That's like where you fly the plane carefully. You might not crash, and you might crash, but you have to plan for the eventuality. That's what possibility is really all about in doing software specification. There's an eventuality that something might happen, and you got to plan for it. Okay, so all these different options are the different options for Q and R. So P implies Q. We didn't come up with a value for P implies Q. It could be either way because we have all four values. But the thing is, not only is P impossible, but Q is possible and Q is also not possible, but it's not true, right? It's just a possibility. It depends on which of those four states you go in. So anyways, this strong implication keeps you from accepting nonsense like Chewbacca lives on Endor, therefore you must acquit. And it says in all futures where possibly P and Q. I'm sorry, it's right. In all futures where possibly P and P necessarily implies Q. But because P is impossible and there is no evidence that Chewbacca lives on Endor, right? It's possible, but it would be necessarily true if you had evidence that it were true. And Chewbacca lives on Endor would not necessarily imply that you must acquit, right? So strong necessarily basically means in every universe it would have to be the case that if Chewbacca lives on Endor, then you must acquit. And if it were classical logic, this doesn't even need to be true for that to happen. Okay, so that's the end of it. I hope I got through the recording without screwing it up.